You so much. Good morning. It's still morning in Florida. It's definitely morning in California. Welcome to How to Build a 100-Year Parking Structure, Fundamentals of Concrete Construction. Obviously, you're here because this is a AIA-approved course for One Learning Unit Health, Safety, Welfare. My name is Jeff Mosley. I am your presenter this morning. This year, 2024, marks my 41st anniversary in construction. So I have definitely earned the gray hair that I have, which you can't see, but trust me, it's there. In the 41 years of my background experience, 22 of those I was on the construction contractor side, waterproofing, restoration, and concrete repair. I left that dark side of construction, went to the corporate world of BASF and master builders, trained at their labs in Cleveland for a number of years. I've been a fire flood mold restoration contractor, and I am the director of technical services at SINAC. I'm also a 20-year member of CSI. I am the SINAC company spec writer, and I'm a member of the ASTM. I sit on two committees, C9 and F6. C9 is concrete cures and aggregates and admixtures, and F6 is flooring, flooring adhesives, and flooring systems. So, who is SINAC? Your sponsor, if you will, this morning. SINAC is a ultra environmentally friendly company. We can say that for a couple of reasons. One, everything that we manufacture and produce is zero VOC, non-toxic, non-hazardous. We also hold a record currently in Division 3 products for having the longest life expectancy of a product yet to ever be produced, and that is a 60-year life expectancy. We have a great team here at SINAC that are concrete nerds. I'm going to say it that way because that's what I am. We participate in a number of organizations and groups to help make sure that we do something that's unique, and that is we provide you solutions to enhance your concrete's ability to perform as you've designed it. So I want you to think of it that way as we go through this morning's presentation. So why are we here? Aside from learning units, obviously we want to get some education. And my goal, part of my goal as our teacher, if you will, is that I want to break down the barriers and change the way that we think about how we go through the process of not only building, but deciding on what we're going to use when we build. You know, we have to ask ourselves the question, how is it possible that you can continue to do the same thing over and over again and expect different results? But that's what we find ourselves doing with our specifications. So we're going to look at what are the considerations that you need to take into account when you're specifying or building a structure that you want to last for at least 100 years. And that's our goal. So we're going to look at how do we improve our specifications? How do we tell the contractors not only what they should do, but what they should not do? We're going to look at concrete mix design, why it's important, what do you need to know about it, placement techniques, and curing methods, all in order to achieve that end goal of ensuring that that structure has a comprehensive warranted traffic debt process in place. We're going to look at environmental concerns, right? How do we choose the products that we choose? We're going to look at the application techniques, ways to improve overall quality and reduce the incidence of damaging the structure while we're going through the process of product application. We're going to look at some time savings and some combined systems approaches to make sure we get overall concrete placement correctly done. So it's a big challenge, but we'll get through it this morning. Trust me. All right. In order to build a 100-year parking structure, I really think it's important that we begin with the fundamentals. And so I'm going to go through what I consider best practices or steps that we should take to make sure that we get this process completed. I am a very linear thinker. And so for those of you who have questions during the presentation, I don't want you to think I'm ignoring you. I'm going to walk through a process and a story this morning. So I will answer questions at the end of the presentation, but don't be afraid to add them while I'm talking, because we'll get through and make sure everything gets taken care of for you. So let's look at these 4 points of sustainability. You know, this is not new information. This is not groundbreaking. I'm not introducing something to you that you probably never have seen before, but it is important to begin a foundation of building based upon some steps that we want to take. So When we look at resource efficient construction processes, yes, it's important to use, locally sourced materials whenever we can. And that's a good process. That's a good start. But we need to take this step a little bit further, and we want to think about what is the overall impact of efficiency that we're talking about, from raw materials extraction to the manufacturing process, all the way through the chain of product delivery and actually putting it in place on the job site. How is this going to impact not only our environment, but those working on the job site? And what are the long-term effects that we're going to have once the product is in place? Now, you've got great resources at your disposal that you can help to choose these or verify these. You've got HPDs, EPDs, declare labels, life cycle assessment documents. All there is filtering mechanisms to help you make wise choices. So when we talk about the next one here, reducing and eliminating waste or pollution and environmental degradation, this is not just waste from the manufacturing process. We have to think about the materials as they get to the job site. In the flooring industry, we talk about less cutting, less trimming, fewer bond lines. Those are the same things we want to bring to a parking structure. We want to make sure that we have as few steps as possible in the overall process to reduce things, make it simpler, keep it easier, and reduce our waste. And that's really what we want to look at. And that's also reducing waste over the life cycle of the structure involved. The longer a system lasts, the less components, the less variables, the less potential for failure, the better quality and the longer life cycle you're going to have. Now, when we look at protecting human health and improved productivity, this is usually associated with building envelope. And that's true. But when we talk about a parking structure, we can take it one step further. There are things that you can incorporate into your design that's going to help you, not only with the contractors or the people doing the construction, but how can we improve the health and productivity of those individuals occupying the structure once it's complete? So we're going to look at simple steps. Can we reduce the amount of grinding or shot blasting on the concrete, reduce the incidence of silica dust production during construction, making sure post-construction we've got proper lighting so that we can improve efficiency and safety, making sure that there's techniques of integrating newer designs and newer technologies like photocatalytic scrubbing inside the structure to reduce vehicle tailpipe emissions. These are things that you can actually do now. And we'll touch on some of those as I get through the presentation today. But the goal is here, obviously, making sure that we can achieve this last step, and that's longevity. Believe it or not, longevity is the truest definition of sustainability. The longer something can last without having to be touched, maintained, or repaired, the more sustainable that thing's going to be. And the mere fact that we know we can build concrete structures that will last at least 100 years or more is just the beginning of what we can do. We can actually take it further than that. And there's proof. There's proof that we can take it further because obviously, if we're going to take on the challenge of building a 100-year parking structure, we need to make sure it's possible. And it is. You can look back. Now, there's lots of people out there in the world today that say, hey, the Romans invented concrete. Obviously, we have access to Roman technology or we've lost it. But honestly, the truth is the Romans didn't invent concrete. That's a myth. I mean, this is the nerd in me coming out. Actually, the Assyrians created it or invented it, and then they were conquered by the Romans. They took it back to Rome and they built things, but that's not why we're here, right? So this slide, I want to explain a few things here. What you're looking at in this core sample, why am I showing you a diver? Obviously, that's the question, right? We're talking parking structures. And the reason I'm showing you this is I want to challenge the way that you think about concrete. Now, this core sample comes from the breakwaters of Alexandria in Egypt. It is over 2,100-year-old concrete. And it's interesting in that it's harder, denser, and stronger than anything we build with today. And yet it's been subject to a saltwater environment, the harshest environment that we can imagine for construction. And it's lasted for over 2,000 years. But as architects, as design professionals, I think our goal, your goal should be to build aesthetically pleasing, functional structures that last a long time. Now, almost everybody in architecture recognizes the bottom photo here. This is the Pantheon in Rome. And the reason I'm showing you the Pantheon is not because they park cars there, they don't, but It is the oldest continuously occupied cast in place concrete structure in the world. And so it is possible to build a concrete structure to last for almost 2,000 years. And yet, the average life expectancy of structural concrete in America is about 65 years. So we got a little ways to go. So the question then becomes, well, what changed? Why is it that the Romans and others can build things that last centuries and we can't even build things to last 100 years? And honestly, we lost the information. If you think about it, we've had to suffer war, disease, famine, and pestilence. And as we've come out of this process of relearning, reinventing, and redesigning things, that's literally what we've had to do when it comes to concrete. Structural concrete use in America is only 127 years old. It's been around a little bit longer than that, but for structural concrete, it's only 127 years old. So we got to do a little bit better. Now, as we've come out of this dark period, if you think about this in a linear process where we've come from in our past, we've gone through the process of modifying and changing our mix designs. We started taking waste products and dumping it and burying it in concrete to make it go away, but also because we knew we had benefits. Fly ash cooled things down some. We invented secondary supplemental cements, right? Beginning in the 1970s with the author and publishing of a book called Silent Spring by the author Rachel Carson, we recognized that we had to do better to improve the overall quality and health of those around us. And so we started developing VOC laws to control volatile organic compounds. EPA has managed to walk through regulations on how we process and how we manufacture materials. And all of these things take place over time in a linear fashion. And that's kind of a, well, I call it a duh statement. You're like, well, yes, Jeff, we obviously know that. Intuitively, we do know that. But in reality and in the specifying world, we have a tendency to forget that. But because of all this change and all this fluid mobility that takes place, you, the design professional, have really been burdened with an unrealistic expectation from your customer or your client. And that unrealistic expectation is what I call the most unrealistic job description I've come across, and it's yours. If you think about it, the expectation, the burden that's on your shoulders today is you're supposed to know all of the changes that have taken place in 127 years, if not all the way back, but at least for the last 3 or 4 years. You're supposed to be aware of all the technological advances that have taken place, integrate those advances into your design process, and then build your structures faster than you've ever built them before for less money. That's literally what your expectations are. And because of that expectation, we end up falling victim to a problem. And that problem is siloed specifications. Now, what do I mean by siloed specifications? Well, back in the 1980s, we started a problem. We disassociated as firms. We started farming out independent consultants, engineers, and over time, they became the controllers of divisions. And so we inherit divisions as specifications, but as the keeper of the book of the master, you're responsible for understanding that. And this leads to this under knowledge or ignorance in our industry. So what am I talking about? Because I don't want to offend anybody here. What's the ignorance? The ignorance is not knowing where everything came from. And actually, there's a great film or movie quote to illustrate this. If you've ever seen the movie Jurassic Park, the first one, the good one, there's a scene where the mathematician Malcolm is kind of chastising the scientists about what they're doing. And he says, listen, you didn't earn the knowledge, right? You were flown out here, handed this book of information, and you got so busy going forward asking if you could do something. You never stopped to ask if you should do something. And that's where we find ourselves today. We're using products and systems and integrating steps that are siloed by an engineer in Division 3 or a waterproofing consultant in Division 7 or a sealing and coatings consultant in Division 9, and they're not cross-divisionally communicating. And because of that, we end up doing the same wrong things over and over again. So that's what we need to improve. So let's talk about concrete, right? What is it exactly? Well, we all kind of know what it is, right? It's the #1 building material in the world today. Whether you calculate that by tonnage, square footage, or dollar amount, we build more with concrete than any other building material in the world. It's 90% of the mass of your parking structure. So what is it? Well, according to the American Concrete Institute, it's a what? It's a composite material that consists essentially of blah, 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 blah. That is an absolutely boring definition. It is. It's a boring definition. I like my definition. Think of concrete in this fashion. It is a complex, three-dimensional dynamic building product. And if you think of it that way, it's no longer a util, it's no longer an object, right? It's a three-dimensional dynamic building material. And so we want to understand how it acts, how it behaves, because it does have a distinct behavior. And when you know how it behaves, we can control and prevent issues like cracking and dusting and spalling and all kinds of other problems that we don't want to have happen, right? So let's take a quick quiz in your own mind because this is not a live in-person presentation. I want to ask you, are you aware of, did you know that concrete has 3 states in its life cycle? See if you can choose the 3 states really quick in your mind. I wish altered states was one of them, but unfortunately it's not. So this is the concrete life cycle. It has a plastic state, a curing state, and a hardened state. And it's important to understand each of these 3 states so that we can positively affect the concrete while it goes through its life cycle. And positively affecting it's going to improve our process. If you're to graph it, this is really what the concrete life cycle looks like. The moment of catalyzation is when the process begins. And notice this life cycle, like construction, is a one-way linear process. It's important to know that because once you transfer from one state to the next, you cannot go backwards. So it's really incumbent on us to understand each state of the concrete life cycle. The plastic state is its wet fluid workable state. This is the time that we control the water in the mix in the truck and placing it. The curing state is not only a standard period of time or a condition, but it's also a process. And this is where words can get confusing. Not only is it a state, it's a one-way linear chemical reaction that's taking place in your concrete. It's subject to change due to temperature and humidity. You can speed it up, you can slow it down, and you can stop the process, but you can never restart the process. And really, you can drive on it, you can function, you can work on it in the curing state and still maintain it. The hardened state is the last state of the life cycle, and this really just begins the moment the curing process stops. That's when drying may begin. But we don't want to rush this because we want to ensure proper hardness, proper durability, and extend this life cycle as long as possible. The longer we can keep the curing state in effect, the better the concrete's going to be. So let's look at the plastic state. This is when you can most affect it with outside influences. This is when we can manipulate it and put it in the form that we want to do. It's the most malleable state, right? So we want to be careful about the influence that can affect it in this state, right? I can't confirm or deny that there might have been a good barbecue after the placing of this slab, but it is easily affected at this point. So we want to know that when we go into it. Now we transition into the curing state. And remember this, curing is not a product. I can't tell you how frustrating it is to hear people say, well, I specified a cure. You can't specify a cure. There's no such thing as cure. Cure doesn't come in a bucket, okay? Not only is curing a state in the concrete life cycle, it's a one-way linear chemical reaction that you have to ensure. And you need to make sure that you can facilitate concrete's ability to cure for as long as possible. And we do this by providing adequate moisture, temperature, and time. Those are the things that we need to have in place. And it's critical that we maintain this curing process as long as possible. I love the illustration of the fire triangle here because it really helps drive home the impact that we're having with the curing state. If you remember basic chemistry, for a flame to exist, right, all 3 sides have to be there. Lose one side of the triangle and the flame goes out. Well, concrete works kind of the same way. You need cement, that's your fuel, enough of it in there to do what it needs to do. You need temperature internally, inside the concrete above 50 degrees for as long as possible. And here's the cool thing. Concrete is exothermic. It creates its own heat from inside. And as long as you have that and a catalyzing agent, which is water here to replace our oxygen, you can have curing. And you only get one time to do this right. Once curing stops, it cannot restart. So we want to make sure that we maintain it as long as possible. The hardened state is simply begins once the internal relative humidity of concrete falls below 80%. Now, that doesn't mean concrete's dry. It just means that the hardened state has begun. And a lot of times we say the hardened state and the drying state are the same thing. It's not. Don't get confused by that because concrete can maintain moisture levels even though it's in the hardened state. But we want to make sure we understand the differences between the three. Now, another problem we have in the industry, not only that we silo our specifications to consultants or experts, we have a problem with language. Language in the English language especially is a problem because far too often we're confusing the symptom of a problem to the actual cause or the illness of a problem. And whether it's either ignorance or laziness, I don't know, but it's a common problem of trying to treat the symptom instead of treat the underlying problem or illness. So in order to prevent the problem from happening, you need to diagnose a couple of very common concrete problems that we run into. And almost all of your concrete problems begin the day the concrete is placed. And so if you know that, that's where we're going to focus our attention. The first 72 hours, if you will, of concrete placement. Now, in North America, I said we've only been doing structural concrete for about 127 years. In that time, there's only two kinds of concrete you build with, cracked concrete and concrete that's going to crack. Now, I know that's a bad joke, but the reality is concrete is designed to fracture. It will break. That's why we put joints in them. But the cause of all the cracks need to be boiled down to understanding one thing. It's simply a loss of tensile strength. So we want to improve tensile strength in concrete. And by improving the tensile strength, you will reduce the incidence of cracking. Now, when it comes to language, another problem that we have, and I hear this all the time, all concrete cracks are plastic shrinkage cracks. That is a myth. It is not possible for a crack that shows up 7 days later to be a plastic shrinkage crack. Plastic shrinkage cracking only occurs in the plastic state, and it's usually rapid loss of moisture or misapplication or misuse of admixtures, water starving the mix, if you will. Crazing cracks, map cracking, or curing related cracking happens during the curing state. And these can be affected through a number of things that we want to pay attention to. Mostly it's mixed design, but we also want to look at proper techniques of finishing so that we can prevent things from happening. In the curing state, usually it's surface moisture loss. So here's where we like to make sure that we have special tools available for the contractor, such as evaporation retarders and finishing aids. But regardless of reason why it cracks, we want to make sure that we're controlling it at the right time. And then, of course, drying shrinkage cracks. This is because, unfortunately, we spend so much time focusing on placing and finishing and curing the concrete, we neglect to control the rate of drying. And this is a common occurrence because traditional curing methods, even poly, burlap, wet curing, even 309 membrane forming compounds, only address the first couple of days of the concrete's life cycle. None of those, not a single one of those options, can regulate, cure, or control the rate of drying. Because as soon as you remove the object, right, it no longer functions. So when you're looking at drying shrinkage cracks in the hardened state, you want to make sure that whatever curing method you're doing, and effectively you should be considering a curing agent, because those will actually extend the life of the concrete by controlling drying. And we can get into curing agents at the end if we have time during Q&A. So let's talk about some other symptoms, some problems, right? When we look at dusting, this is a problem. Not only is it a problem for health and safety because that silica dust is harmful, but it's already degrading or deteriorating the surface of our concrete. And we want to make sure we can prevent this from happening. The American Concrete Institute says there's 8 reasons for dusting. Almost all of them are water related. So the very first thing you have to do under execution for concrete placement in your spec, no water added. Please tell the contractor what not to do. Once that truck leaves the batch plant or the yard, do not add water to it. You have tools, you have evaporation retarders, you have finishing aids, you have things that you can add into your specifications to ensure proper quality control. And this is what we need to maintain, controlling the water so that we don't add it. Curling, another problem that we run into that we don't think about often, especially in a parking structure. This affects flatness and levelness. And you say, well, it's not that big of a deal, except curling can accelerate the deterioration of the slab. So what happens here is, remember, concrete's a three-dimensional dynamic object. As moisture leaves the joints faster than everywhere else, it causes deflection, or the corners to curl up or rise up. And then as we drive over them, we'll break down and we'll fracture that, causing accelerated deterioration of our structure. So we want to make sure we do something here that's different than what you've ever been told. You're going to cure all 6 sides of your three-dimensional dynamic object equally. Controlling the variables of moisture loss will reduce or eliminate curling and save you from major repair. All right, spalling, freeze thaw. This is another problem we have to pay attention to because we don't want to break down the surface of our structure. It is possible to place, finish, cure, and seal a product all within 5 days to make sure we don't end up accelerating corrosion of our steel, getting penetration of de-icing salts, which I know you guys are in Florida, but you do get weather down there every once in a great while, right? But we want to make sure that we can prevent this, and we can do this by making sure we do the proper process. Here's the deal. All of the problems that you are associating with concrete, loss of tensile strength, issues with cracking, issues with curling, all really boil down to the permeability of the concrete. They're all symptoms telling you the concrete is exchanging moisture at the wrong rate. This is the illness that we want to control. This is what we want to make sure that we can reduce to as low a level as possible. And this will extend the life of your structure beyond measure. It really is that critical. So let me recap a few things, right? So we know the history of concrete. While it's been around thousands of years, structurally, it's only been here for about 127. You now see and kind of can visualize the 3 states of the concrete's life cycle and why it's important. It's a linear process. We've gone through that. We've looked at the differences between the symptoms of a problem versus the illness, the symptoms, the spalling, the dusting versus the permeability. And we know that we can prevent the illness from happening if we can control the 3 states of the life cycle. That's what we're going to do. We've identified all that. So let's go into some best practices. How are we going to build this thing to last 100 years? And really simply, best practices for these 3: product selection, concrete installation, and product application. So product selection, step 1. Here are your 4 pillars of product selection. This is how we choose the right product for the project. And these, like construction, like the concrete life cycle, like time itself, are linear. You have to do them in sequential order, and each one has to be taken into consideration when choosing a product. Now, sustainability, compatibility, performance, and warranty, right? What's missing? Now think about it. There's one category that almost everybody references, everybody thinks about, everybody says is the primary leading factor in why we choose a product. And it's not here. It's price. You see, price should not be a category for choosing a product at this stage. And let me tell you why. I truly believe if you go through this process, sustainability, compatibility, performance, and warranty, whatever you're left with will be the most cost-effective solution for your project, even if the bucket price may be more than you're used to seeing. So let me give you an example. We had a customer, matter of fact, the facility that's on the slide is a parking structure in San Diego, California. During the construction process, the specification had a water cure or a curing compound. The contractor was not going to water cure this. And so they did an evaluation. They had product A, which is a 309 membrane forming curing compound that was 6 cents a square foot. Product B was a new product category called curing agent water cure equivalent type. It had a product cost of 10 cents a square foot. over 1 million square foot parking structure. The customer did not follow these 4 steps, chose the 6-cent product to save 4 cents a square foot. Now, fast forward 3 months into construction. The waterproofing contractor showed up to install the deck coating. The curing compound that was chosen was not compatible with the deck coating. Therefore, the owner and the contractor had to remove the curing compound. They had to then resurface the top of the slab and install a special primer because of the profile, costing an additional $1.20 a square foot. Now think about that. They saved 4 cents by not going beyond this step and ended up spending $1.20 at the end of the job. So it's really important we look at project value, not product cost. So when we talk sustainability, remember those first 4 pillars. You have tools today that we have never had before that are at your disposal. Third-party, independent, verifiable processes like your life cycle assessments. Anytime you're looking at a product evaluation for sustainability, do not rely on the manufacturer to tell you. Always go look at third-party verification, cradle to grave. What about HPDs, health declarations? These are there to help you, right? It's not just simply listening to what the contractor offers as, hey, this is the cheapest thing. Also, look at secondary product or project impacts. Is the product that you're going to be producing or specifying, is it going to require grinding, shot blasting? Is it going to improve or degrade the surface to have future steps? Is it compatible with everything? Are we going to have issues here? These are the things that we want to take into account. When we talk about compatibility, the next one, is the product that you're specifying in Division 3, is it going to be compatible with everything that comes in the future? And consequently or inversely, is it going to be compatible backwards? This is really, really critical, people. We want to make sure that everything is compatible. And if a manufacturer of a product cannot state in writing that their product is universally compatible backwards and forward with all future products, maybe you shouldn't consider it in your specification. Now, performance is the key. We want to write a performance specification, but we start out specifying that and we end up getting this. What happened? Well, what happened was we didn't follow the categories, the process of product evaluation. We wanted a specification that provided performance. We wanted high durability. We wanted a long life cycle. We wanted no maintenance. And yet, because of substitution requests, RFIs, and value engineering, if you're not following the step at each stage of construction, you're going to be left with less than you specified. And that's what we want to avoid. All right, warranties. I'm not going to go into deep here. Just know you have a type of warranty, a duration for the warranty, and a scope for the warranty. Read the fine print. Make sure any substitutions for what you specified meets the criteria. And I would recommend putting all the warranty conditions in each section so that future sections know what the warranty requirements are. And make sure they're real. Look at the exclusions, look at the fine print, because I've seen 30-year warranties for traffic deck coatings that have to be inspected every 5 years. And then you have to pay to do maintenance and repairs, or otherwise you lose your warranty. That's not a 30-year warranty. So again, do your due diligence. All right, concrete installation. Here's your best practices. We want to make sure that we can improve this, right? So why are we going to look at these things? Because you say it's a parking structure. These are the steps that we want to take and pay attention to. First step, underslab vapor retarders. Now, this has typically only been looked at for building envelope because of flooring. But remember, three-dimensional dynamic object. We want to make the concrete last as long as possible. There are times where you're building a structure on soil that's contaminated. Even though it passes the EPA requirements, what's in there? Could be sulfates, could be nitrates. We want to use this as an under-slab curing blanket and a soil separator. Both of those will extend the life of your concrete. And if you don't do this, you can't add it later. You get one chance to do it, right? Again, linear process. Then we want to talk water cement ratio. Now, we don't usually bring this up, but this is really important. The highest water cement ratio you should ever use in construction is a 0.50. And that's because we want to maintain low permeability. But we want to look at this. So if you don't know, just simple math, the water cement ratio is pounds of water divided by pounds of cement. And therefore that gives you a ratio. Now, we want it to be as low as possible because we know that humans make mistakes. And we know that contractors will add water even when you tell them not to. So the lower the water cement ratio, the better you're going to be. I usually recommend a 4 or 5 or less. Now, the industry still has some hurdles to overcome, right? And one of those hurdles is the insanity that is the concrete industry. And that's this, just so you're aware. This is where we run into problems, okay? Everything that goes into that truck is calculated by weight. That's how we get the ratio. It's pounds divided by pounds. That also means it's pounds of sand, pounds of rock, and those admixtures, those liquids, they have to be measured in pounds, not volume ounces, hundredweight ounces. I've had issues in the job sites where people are adding things by volume into the truck. They have to be calculated by weight. But where we really get stupid as an industry is everything that comes out of the truck is calculated by volume. So we have a disconnect between the concrete finisher and the engineer writing the spec. That can be a problem. All right, placing and finishing the concrete. We've gotten to the day where we're ready to pour everything. We've got a good mix design. We've got low water cement ratio. We know that's the key to keeping the permeability low. What are we going to do wrong? How do we prevent problems from happening at this point? All right. So, product spotlight for you. When we get to the day of placing concrete, your specifications should really include under curing related materials, not just curing products, but curing related products such as an evaporation retarder and a finishing aid. Two different products, two different categories. They're not interchangeable. So it's important to have them both there. And we want to make sure that we get this taken care of properly. So what else can we do here? Let's look at product application. We've done our due diligence. We've got a good specification. We've made sure we've got the right concrete mix design. What are the next steps? Curing properly, because that doesn't mean we're done. Just because the concrete's on the ground doesn't mean we walk away. Then we need to move on to either waterproofing the concrete or sealing the concrete, which is better. And can we clean up the air? And I'll show you that one too. Before we get there, we have to overcome a problem in our industry. We are constantly writing performance specifications, but we're not using performance criteria. Here's what I mean. ASTM produces 4 types of document: a practice, a guide, a specification, and a test method. You should not include a specification from ASTM in a performance specification for construction documents. I know that's controversial. You'll see why in a moment. But a water cure method is not the same as a curing compound. They are not equal. And that's why we keep running into problems, is we're not understanding the differences between what is performance-based, what is chemistry-based. Specifications are chemistry-based. Test methods are performance-based. Always look for a standard test method, especially during substitutions and change orders. This is imperative that we verify performance. All right, not all curing categories are created equal. This is where we run into problems because of master formatting and specification writing. What do? Alphabetical numerical order, meaning we list things in alphabetical numerical order. Even though ASTM numbers, the higher the number, the newer the product, the higher the performance. So we run into problems. But just know that not all are created equal. If you want to make sure we're running through the process, you're probably going to eliminate curing compounds from your spec. I know that's sacrilegious to state it, but we can do it because we want to make sure we do our job right. All right. Quick quiz. Do you think all of those steps are equal? Well, obviously the answer is false because I just told you not all curing categories are the same, but that's your standard master format. I would challenge you to consider reorienting this, changing this process slightly. I can go into detail offline if anybody wants to know how I've done it. I've radicalized this process. All right. What are ramifications of using the compounds? We never talk about this. They're in everybody's specification because nobody has gone through the compatibility process because we've siloed our specs to only looking at division 3. But if you use a 309 compound and not a curing agent water cure equivalent type or not a wet cure method, you will increase the rate of curling. You will prematurely dry. You will be subject to all kinds of weather events. These products have never even been tested on concrete, people. And I know that sounds crazy, but I can prove it. They're going to leave your concrete permeable and they're not compatible, which means we're going to remove them. We're going to shot blast them. We're going to grind them. Dissipating cures do not dissipate. If you want to build a 100-year structure, you're not going to use these products. What else is there? Well, we know we have water curing, but it's difficult. They say, how do you water cure a slope, Jeff? It's hard. We have time delays because contractors are always waiting for something, right? They're always in a hurry. We don't want to run the risk of accelerating the project to the detriment of the project. So in the past, these are what you've been told, okay? Not all curing methods are equal. We know this. But if you're going to build a 100-year structure, you want to have the highest quality concrete. We want to affect it properly. And here's how we do it. These are what you've always been told. Dam and flood, poly sheeting, absorptive covers, water fogging, all time consuming, all difficult, all labor intensive, all shunned by the contractor, which is why we keep ending up with compounds that don't work. There's a new product category out there, curing agent water cure equivalent type. Think of these as liquid blankets. They're penetrating chemicals that act or form a membrane under the surface so that they're universally compatible. There's multiple manufacturers that have met this standard. I want you to be aware of it. Okay, after we've cured the concrete, let's talk about how we're going to seal it. Now, traditionally, we water cure because we know we're going to put a penetrating sealer over the top, right? And if you're a movie buff, you'll catch the quote, 60% of the time they work every time. I know, let that sink in. But what do we want to achieve? Do we want to repel water temporarily, or do we want to waterproof the structure so that water never comes in? We need to pay attention. Water repellents are temporary. You can break the surface tension and get water to go in. They're not designed for horizontal traffic surfaces. They are designed for vertical overhead columns and beams. But we've made a mistake somewhere along the line and started using them on the wrong parts of the structure. Waterproofing sealer. This is a case study. This is a parking structure that was built in 1992 in Redmond, Washington. It is the parking structure at the Microsoft campus in Washington State. It was cured with a curing agent, so they've been around since the 90s. It was then sealed with a waterproofing sealer, permanent sealer, one-time application, never been reapplied since 1992. And you can still see a broom texture on the surface of this deck. And it does get cold in Redmond, Washington. So you can do this. Look at the types of sealers, penetrating sealers, waterproofing coatings. What's the warranties? Make sure we get all that answered. All right, the last thing you can do, this is new, this is state-of-the-art technology that is available on the marketplace. There are 3 ways of achieving this at varying costs, but I want you to be aware of them. There have been significant advances in technology where you can now convert a concrete structure into a photocatalytic converter. What that means is we can actually exchange with tailpipe emissions and clean the air inside your structure, up to a level of about 60% reduction in tailpipe emissions. Totally different presentation. Just want you aware of that. If you want to investigate it, I can provide information later. All right. I want to challenge you to challenge your specifications. Here's what we need to do. Don't be afraid to ask if things should be done, right? Remember Malcolm? Remember Jurassic Park? We have to make sure we're performance basing our specs, not chemical or molecular makeup. because some chemistries are not compatible. We also want to make sure we control and improve the specification. Make sure we're communicating. Ask Division 7 and 9 what conditions they need to work properly and have 3 give it. It's easier for 3 to do it in the beginning. Also, does a substitution request or product change the product cost or the project cost? Go back to your best practices for each step of the process. And then always use the 4 pillars of product evaluation to do that. We know we can do it. And remember, it's the permeability that we want to control, not the symptoms of the steps that we've been told in the past are our problem. And implement these best practices. If you do that, you can end up with this. You can end up with a properly selected product system in your specification. You can ensure compatibility across divisions. You can follow the installation processes to get optimal performance, and you can apply the right curing agent and the right waterproofing and sealing and get a 100-year structure. It is possible. We can do this. All right, this concludes the credited AIA portion of the presentation. I've got a number of questions here. I will try to answer them as quickly as possible. Any of you that want additional information or learning opportunities, you can scan the QR code on the screen. It will take you to my personal account, and you can schedule events through me. You can get direct contact. My cell phone is also on here. If you have any technical questions, please do not hesitate to call me on my cell phone. I will answer your questions, but I want you to be aware that you do have access to us. So, got a couple of minutes here. Let me see here. What are my thoughts on a sand bed over vapor barrier under the pour? That is a great question, George. I do not recommend a barrier to be put or a sand bed to be put on top of the vapor barrier, and let me tell you why. You've now created a reservoir or a bathtub. And so what we want to do at this point is make sure that we don't trap moisture. Stego has a fantastic video on their website that will show you why we pour directly on the membrane. Now, the industry tells you otherwise. Old school concrete contractors say, I can't do that. Yes, you can. Properly curing your concrete and pouring directly on a barrier will reduce curling. And I've done this in some of the harshest climates in the world, in high deserts, in Phoenix, up in Reno Market. It can be done. So let's see, what else do we have? Leslie's question, has the concrete industry considered improving environmental impacts of the plant that makes concrete? That's part of the question. Yes, they have. The industry has been taking steps to use recycled content in the processing of concrete at the plant. This has resulted in a new type of cement that is on the market called 1L cement. There are some hiccups with 1L cement that you need to take into consideration, but it is possible to improve. Let's see. We need more plants out here. Yeah, we do need more plants. It's difficulty. It's a difficult process. We'll get there. It's a slow process, as is all construction. Remember, you're writing specifications today for projects that won't be built for probably 2 years. Now, you have an entire industry of crotchety old people that don't like change. We park in the same parking spot all the time, and it makes it hard. So we will get there. And we'll get there when you start challenging us with the right specifications. It's a two-way street. And then finally, I've got one last question here. It looks like parking garages that need to morph. We haven't looked at that. This question was from Donna. We haven't looked at changing the parking structures for use as a system. I don't know that that will happen right now. I suppose at some point we could look at that. I don't know what that would look like other than maybe storage, but great questions. Guys, thank you all so much for taking the time to log in today and listen to my presentation and my diatribe of concrete nerdiness. Again, feel free at any time to reach out to me directly if you have any questions. If something pops in your brain and you go, hey, what was that? Let me know. I'm happy to share information. Our website is full of critical information. You can go to our website at signac.com and you can download a free copy of my book, The Architect's Guide to Concrete. You can get a free copy there. It's a really good field manual tool if you need access for questions. You know, a contractor comes and says, well, that's just normal. All concrete does that. You can say, oh, no, no, no. The nerdy guy from California walked me through the process. And according to this book, that's not normal. And here's how you're going to fix it. So it's a great tool. Information is power. And the more information we have, the better off we're going to be. So I guess I can ramble for 5 more minutes. I don't know since the education portion is over. Oh, I don't know if, well, I can run the risk of asking for